Coming up on SpaceTime, counting down to the Australian total eclipse of the sun. A new study suggests Snowball Earth might have actually been a slushy ball. And discovery of a nearby binary brown dwarf system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Sky watchers from all around the world have made their way to the outback Western Australian township of Ningaloo for one of the most spectacular events on the astronomical calendar. Nothing less than a total eclipse of the sun. At 11:29 a.m. on Thursday, April the 20th, Western Australian Standard Time, the sun will disappear, suddenly turning day into night as the moon blocks out its life-giving light for a minute. Although Earth usually experiences a solar eclipse every 2 years or so, they're still exceedingly rare at any single location on the planet, with only one total solar eclipse likely to occur at any given location every few hundred years. And this Thursday, it's the people of Ningaloo in Northwest Cape who will be in the prime position. The rest of Australia will experience a partial eclipse, and the closer a person is to the path of totality, the more the sun will appear obscured. The eclipse will actually start out in the middle of the Indian Ocean, before gradually moving in a northeasterly direction over Northwest Cape in Western Australia, and then continuing across the Timor Sea before reaching Indonesia and the Pacific Ocean, where it will finally disappear. After Thursday's eclipse, the next total eclipse in Australia won't occur until the 22nd of July 2028, just over 5 years away, crossing the Kimberley region of Western Australia, then the Northern Territory, southwestern Queensland, western New South Wales, the Blue Mountains, and passing directly over Sydney, before crossing to New Zealand and disappearing in the South Pacific Ocean. Solar eclipses happen when the moon's orbit lines up so precisely that it passes directly between the Earth and the sun. It's an incredible game of orbital mechanics and geometry. You see, the moon's orbit around the Earth is inclined by around 5 degrees compared to Earth's orbit around the sun. So normally, the moon's orbit appears to cross the sky slightly above or below the path of the sun. But roughly every 18 months or so, the lunar orbit places the moon directly between the sun and the Earth, resulting in a solar eclipse. Eclipses happen because although the moon is 400 times smaller than the sun, it's also 400 times closer to the Earth. And so, by pure happenstance, the two appear to be about the same size in the sky as seen from the surface of the Earth. When the sun, moon, and Earth line up exactly, the Earth experiences a total solar eclipse. As this occurs, the moon begins to slowly pass in front of the sun, and a partial lunar shadow, or penumbra, crosses the surface of the Earth. Now this can last for over an hour or more, as more and more of the sun is hidden by the face of the moon. Then, just before totality occurs, the crescent sun converges into a single brilliant white diamond of sunlight, as the last bits of the sun's bright disk shine along the edge of the moon, and the first glimpses of the faint corona, the sun's atmosphere, create a ring around the moon, an effect astronomers call the diamond ring. In the last fleeting moments before totality, the diamond ring breaks up into a string of beads created by the sun's rays shining through low-lying valleys between the mountains along the limb or edge of the moon. Once this effect, known as Bailey's beads, ends, the moon has completely covered the entire disk of the sun, and we're in totality. During totality, the darkest part of the moon's shadow, the umbra, crosses the Earth's surface. People along the path of totality will get to view a total solar eclipse, lasting anywhere up to 7 minutes and 31 seconds, but usually far shorter. In this case, Thursday's eclipse will last about a minute. On Thursday morning, totality begins at exactly 11:29 and 50 seconds, Australian Western Standard Time. During this period, the skies will go dark, stars will appear, and it will suddenly get noticeably cooler. Birds will start roosting, shadows will take on unusual crescent shapes, and you'll be able to see the sun's tenuous outer atmosphere, the corona, glowing a milky white. Often, explosions of the sun's surface, called prominences, will appear as spectacular bright pink or red clouds stretching high above the lunar limb. The path of totality can be up to 272 kilometres wide, although usually a lot less. In Thursday's event, it'll be about 40 kilometres across. And the further away you are from the centre of the path, the shorter the eclipse duration will be. Now, if you're outside the line of totality, either to the north or south of it, you'll see a partial eclipse, which only part of the sun's disk will be covered by the moon. The reason the total eclipse is only visible over a small part of the globe is because the moon's shadow is relatively small when it falls on the Earth. On average, the moon orbits the Earth at a distance of 384,400 kilometres. But the moon's orbit around the Earth isn't a perfect circle. In fact, it's slightly elliptical, meaning one part of the orbit will be a bit closer to the Earth, about 357,000 kilometres, that's called perigee, and another part of the orbit will be a bit further away, around 406,000 kilometres, known as apogee. When the moon's orbit takes it a bit further away, the moon looks a teeny bit smaller in the sky, and if that coincides with a solar eclipse, it won't cover the entire face of the sun. So, instead of a total solar eclipse, the moon's passage across the sun creates an annulus, a ring of fire, as light from the sun surrounds the dark moon, resulting in what astronomers call an annular eclipse. Solar eclipses are accompanied by a lunar eclipse occurring either 2 weeks earlier or 2 weeks later. That's due to the same alignment which caused the solar eclipse. Lunar and solar eclipses occur with equal frequency, but lunar eclipses are seen over a far wider area of the Earth because the Earth's shadow is larger and therefore covers more of the lunar surface. A lunar eclipse occurs during full moon, when the sun, Earth and moon align. During this event, the moon passes completely through the Earth's dark shadow, or umbra. Even though Earth completely blocks out sunlight from directly reaching the surface of the moon's still visible during a total lunar eclipse. You'll see the moon gradually get darker and then take on a rusty or blood-red colour as light from the sun refracts through the Earth's atmosphere and undergoes Rayleigh scattering, leaving only the longer red wavelengths to reach the moon, as all of Earth's sunsets and sunrises happen at once, indirectly reflecting onto the lunar surface. A total lunar eclipse can also look yellow, orange, or even brown in colour, depending on how different types of dust particles and clouds in Earth's atmosphere allow different wavelengths of light to reach the lunar surface. A partial lunar eclipse happens when only part of the moon's surface is obscured by Earth's umbra. And then there's a penumbral lunar eclipse. This occurs when the moon only travels through the faint penumbral or outer portion of Earth's shadow. And just a reminder, if you are watching any part of the eclipse, only do so if you're wearing special eclipse glasses or handheld solar viewers with solar filters that meet international standards. Make sure your eclipse eyewear meets the ISO 123.12.2 standard, and also ensure that they're not scratched or damaged in any way. Remember, never look directly at the sun. It can cause serious and even permanent eye damage. And that's true even during a solar eclipse. Now, to mark Thursday's eclipse, the CSIRO has published a new book simply entitled Eclipse Chasers. It was written by experts Professor Nick Lom and Dr. Tony Stevenson, and it looks at humanity's long-held fascination and pursuit of these awesome astronomical events. It includes some spectacular photographs and maps, stories by eclipse hunters, the contribution women have made to various eclipse expeditions, and the cultural traditions of Australia's First Nations people regarding eclipse events. Tony Stevenson says the book's a practical guide to viewing and understanding these rare and wonderful events.
Solar eclipse is quite a rare phenomenon because it's when the moon, the Earth and the sun are aligned for a very short period of time. And what happens is that the moon completely covers the sun, and it's the shadow of the moon that creates a track, a shadow track across the Earth for totality. Either side of that track, you can see a partial solar eclipse, but that's not nearly as spectacular as being in that very narrow, never more than 250 kilometres wide path of the moon's shadow.
Now, when one looks at an eclipse taking place, it comes through in various phases, doesn't it? We firstly see the moon appear to take a bite out of the sun. What happens then?
Well, that's a very interesting time for me because you do see that the moon sort of progress across the sun, and it can take quite a while. You know, the eclipse that we've got coming up has a very, very short period of totality, which is when the moon completely covers the sun, if you're in the right spot, as I hope to be in Xmas. But the partial phase of the moon partially covering the sun, that will be seen from many other places. And it's still worth observing with the right equipment very safely, because it is interesting to sort of see that relationship between these three bodies. And the timing of an eclipse was very important in helping understand the distances in the solar system, just as the transit of Venus was important. And people might remember the one or two of the recent transits of Venus and perhaps know about others before that. But these phenomenon where we can actually do timing and calculate then distances from that timing, that was very, very significant. But it's the total eclipse that is most significant scientifically and was in the past, because when the moon absolutely covers the sun, you can see then a phenomenon called the corona. And that, it looks like a bit of a halo, and it's different with every eclipse, but that was able to be analysed using spectrum and understanding the chemical nature of the sun through that analysis.
Now, you and Nick Long have just collaborated on a new book. Tell me about it.
Well, our interest began quite some time ago, Stuart. I was manager of Sydney Observatory. Nick Long was the curator. And we were looking through images, past images. In those days, everything wasn't online like it is now. But I saw an Einstein shed on the race course of Gundawindi in Queensland. And this seemed a bit peculiar to me. You know, what was this Einstein shed? And Nick explained that it was one of the solar eclipse expeditions that Sydney Observatory had been involved in. And I think from that point, we became more interested. And Nick certainly has written several papers which became the basis for this book about the past solar eclipses in Australia and the Pacific. We also collaborated with Dwayne Hummershaw and Uncle Gilla, Michael Anderson, who is a senior lawman of the Uli Nation, to begin the book with First Nations observations of eclipses. And, you know, that is a very, very interesting chapter in that you come away with both the knowledge of what was happening, and some of that is new information to people who aren't Indigenous, but you come away with a very clear understanding that Aboriginal peoples and Torres Strait Islanders really observed and took note of the position of the Earth, the sun, the moon, and how when they came very close to being on that same line, that same sort of trajectory across the sky, that an eclipse was very likely to happen. And this then sort of positions First Nations knowledge as scientific as well as cultural. Then we go through beginning with the 1857 solar eclipse, and the first one that scientists in Australia were involved in. And then a number of other eclipses, one in Tasmania, on Bruny Island, out at Flint Island near Tahiti. And it tells the story really of both success and failure, and a lot of teamwork and collaboration between Australians and people from other nations. And, you know, Britain was always involved in our eclipses after 1857. And then also the American Lick Observatory. That particular expedition was quite extraordinary in 1922. And we then go on to talk about the more recent eclipses, and some people will remember those and tell quite personal stories about those and how they were still adventures. You know, all of these eclipse expeditions involve planning, you know, some sense of going in to the unexpected, checking out the weather, what was the most likelihood of success, taking instruments, and then right up to the present day. And we look at the upcoming 5 eclipses, you know, quite a fantastic series of eclipses beginning on the 20th of April this year.
People who have witnessed eclipses tell me that it's a soul-changing experience. It's something that causes them to change their outlook on life.
Well, I think when you're in that path of totality, that track, and you experience the sky getting darker in the middle of the day or, you know, during daylight time, you feel the temperature drop. You hear the birds stop singing. You hear animals kind of go to their resting place and see them kind of almost go back into a nighttime settling down. You even see flowers close up as if it was nighttime. And it is a sort of whole body experience that doesn't happen really in any other way. You can create the visual in a planetarium, but you cannot create the whole environmental experience. And, you know, what I found, and when you read the book, you see that for some reason eclipses seem to happen at that path of totality. You can be in quite extraordinary places. So there's also, I think, for most people, have to travel to a specific place. So it's the sort of anticipation, the unknown. Will it be cloudy? Won't it be cloudy? Will I be in the right place? You know, let's make sure of that. The timing. Then the eclipse itself. And as it comes towards totality, you're counting down and experiencing all of those changes, including a change of light. The quality of light is very, very eerie. It's been described as ashen, but I've also experienced as being sort of almost bluish at times, depending where you are. And then the totality itself and that whole body experience. And then after totality is as you see the diamond ring, as you do just as totality is about to happen, you see this burst of light as the sun's last rays are shown come out of the sort of craters of the moon. You see that as totality is about to happen, and you see that afterwards. And you have this quite exhilarating feeling. And I guess for me, it was about understanding our place in nature and that we're all part of nature. We're not separate. We're humanity. We are embodied with everything else around us.
Has it changed you?
I think it has, because I feel that before that I felt, I love looking at the stars and all the amazing new discoveries that our astronomers are making, also the cultural astronomy, but to experience something myself, and it's the personal, it's the being there that has such an impact. I certainly never imagined I would become an eclipse chaser, which I have become, always planning the next one, and that it would have such almost an addictive quality to it. It's quite, emotional in some ways when it happens, and I can only describe that as being, feeling so small, I guess, within this amazing solar system, and getting that sense of how our planet is positioned in this very, very precious balance between the sun, earth and moon.
Once again, tell us about the book.
Well, the book is available from bookstores and online. Eclipse Chasers, most of the places people go to online have it. It's also available in an electronic copy, so you can download it and read it on your device. It's a social as well as cultural and scientific expose of total solar eclipses particular to Australia. It's really the only book that's been written that picks up both the scientific work that was done in Australia, but also the social, the political, and our First Nations people's experience. It also picks up on the experiences of women who have often been the hidden figures behind expeditions and scientific work, and research has been done in that field to sort of tell some of the women's stories and their adventures and their contributions. And it does prepare people for an eclipse, what to look for, what to do, how to prepare, and where the best places to see the next 5 total solar eclipses will be.
That's Dr. Tony Stevenson, an honorary history affiliate at the University of Sydney. And this is SpaceTime. Still to come, new research suggests Snowball Earth might have been more of a slushy ball, and discovery of a nearby binary brown dwarf system. All that and more still to come on SpaceTime. As far as we can tell, at least 5 ice ages have befallen the Earth, including one 635 million years ago that was thought to have created glaciers from pole to pole. Called the Marinoan Ice Age, it's named for the part of Australia where geologic evidence was first collected about this event back in the 1970s. Scientists say the Marinoan Ice Age was one of the most extreme in the planet's history, creating glacial ice that persisted for 15 million years. But now, new evidence collected in China's Hubei province suggests that Earth wasn't completely frozen during this event, at least not towards the end of the Ice Age. Instead, a report in the journal Nature Communications claims geologic samples dating back to that period suggested there were at least some patches of open water in some of the shallow mid-latitude seas. One of the study's authors, Thomas Algo from the University of Cincinnati, says scientists have always called this Ice Age Snowball Earth because it's believed that the entire planet was completely frozen over during this period. But if the new evidence can be believed, then it may well have been more of a slushy Earth. The claims, based on the discovery of benthic phototropic microalgae in black shale dating back more than 600 million years. This algae lives at the bottom of the sea and needs light from the sun to convert water and carbon dioxide into energy through photosynthesis. The authors conducted an isotropic analysis, finding that habitable open ocean conditions must have been more extensive than previously thought, extending into oceans that fall between the tropics and the polar regions, and providing refuge for single-celled and possibly also multi-celled organisms during the waning stages of the Marinoan Ice Age. While deep water likely didn't contain oxygen to support life during this period, the shallow seas did. And so that requires a new Snowball Earth model, one in which open waters existed in both low and mid-latitude oceans. It's likely the Ice Age saw many intervals of freezing and melting over the span of 15 million years. And under these conditions, life could have persisted. The study's authors now believe the Marinoan glaciation was dynamic. There may have existed potential open water conditions in the low and mid-latitudes several times. And these conditions may have been more widespread and more sustainable in surface water than previously thought, and may even allowed for a rapid rebound of the biosphere once the Marinoan Snowball Earth period was over. Algo says these refugees of life may even have helped to warm the planet, ending the Marinoan Ice Age. Over time, the algae in the water would have released carbon dioxide into the atmosphere, gradually thawing the glaciers. He says one of the general take-home messages of this study is how much the biosphere can influence the carbon cycle and climate. We know today that carbon dioxide is one of the most important greenhouse gases, and we know how changes in the carbon cycle have an impact on global climates today. Algo says his study raises tantalizing questions about other ice ages, especially the second one during the cryogenian period that scientists also believe created near total glaciation of the planet. He says scientists don't know for sure what triggered these ice ages, but his suspicion is that it was related to multicellular organisms which removed carbon from the atmosphere, leading to carbon burial and the cooling of the Earth. As Jeff Goldblum once said in the movie Jurassic Park, life finds a way. And this is SpaceTime. Still to come, discovery of the first ever nearby binary brown dwarf system. And later in the science report, new warnings about a link between air pollution and lung cancer and even dementia. All that and more still to come on SpaceTime. Astronomers have discovered the first ever binary brown dwarf system comprising two brown dwarfs. Brown dwarfs are failed stars, objects which don't have enough mass to sustain the core hydrogen fusion process which makes stars like our Sun shine. However, brown dwarfs do fuse deuterium, a heavier form of hydrogen which includes a neutron as well as the core proton in the nucleus. And brown dwarfs above, say, 65 Jovian masses can also fuse lithium. Brown dwarfs are classified in one of three spectral types, L, T and Y, depending on their mass and surface temperature, progressively going through later spectral types as they age. While some brown dwarfs are born as such, others start their lives out as fully fledged stars, spectral type M red dwarfs. But eventually they burn off enough of their mass during their evolution to cease core fusion, turning them from red dwarfs into brown dwarfs. Brown dwarfs fit into a category between the largest planets, which can have about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are between 75 and 80 times the mass of Jupiter, or about 0.08 solar masses. The new discovery, composed of two Y-type brown dwarfs, has been reported on the pre-press physics website archive.org and was made using the infrared camera aboard the James Webb Space Telescope. Spectral type Y brown dwarfs usually have temperatures below 500 Kelvin, making them the coolest and least luminous substellar objects so far detected. In fact, you'll find some planets which are hotter. One of the brown dwarfs in the system, catalogued as J033605.05 -014350.4, is a nearby spectral type Y0 brown dwarf first detected back in 2012 by NASA's Wide Field Infrared Survey Explorer, or WISE spacecraft. It's located 32.7 light-years away in the constellation Eridanus. It's somewhere between 8.5 and 18 times more massive than Jupiter, with an effective temperature of between 415 and 460 Kelvin. When astronomers took new observations of the brown dwarf using the Webb Space Telescope, they discovered that it had a binary companion, about 0.97 astronomical units from the primary. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres, or 8.3 light minutes. So these two brown dwarfs are orbiting each other at a distance which is only slightly closer than Earth's orbit around the Sun. Astronomers estimate that this new object has a mass somewhere between 5 and 11.5 Jupiter masses, and an effective surface temperature of 325 Kelvin, making it another spectral type Y brown dwarf. The two brown dwarfs orbit each other in around 7 Earth years, and the system's estimated to be somewhere between 1 and 3 billion years old, although some estimates have put it up to as much as 5 billion years of age. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study warns that exposure to fine particulate air pollution over as short a period of time as 3 years could be enough to increase your risk of developing lung cancer. The findings, reported in the journal Nature, looked at the relationship between exposure to 2.5 parts per million of air pollution and lung cancer in groups of people across England, Taiwan, South Korea, and Canada. The authors say that increased levels of 2.5 parts per million were associated with a higher frequency of EGFR mutating lung cancers, which are triggered by the mutation of the EGFR gene. The authors say this suggests that lung tumours may develop in a two-stage process. First, the gene mutates, then other factors allow the mutated gene to grow and expand into cancer. The authors say the 2.5 parts per million level appears to exacerbate the second process. Now, while we're on the subject, scientists have found a link between fine particulate matter air pollution exposure and a higher risk of dementia. The study, reported in the British Medical Journal, brought together and reanalyzed data from 16 previous studies, looking for various links between air pollution and dementia. They found higher exposure to fine particulate matter, again approximately 2.5 parts per million, was enough to provide a link to an increased dementia risk. The researchers found that for every 2 micrograms per cubic metre increase in average annual pollution concentrations, the overall risk of dementia increased by 4%. The effects were most marked in studies that actively assessed participants, rather than those using passive methods such as electronic health records. The researchers also found a weaker link with dementia for exposure to nitrogen dioxide and nitrogen oxide, but no link was found for exposure to ozone. During December 2021 and January 2022, scientists couldn't find a single nest in a colony of Antarctic seabirds known as South Polar skuas. At the same time, they only found 3 breeding Antarctic petrels and just a handful of breeding snow petrels. The authors say this suggests that unusually strong snowstorms have interfered with the birds' ability to breed. Normally, the Antarctic nesting sites being monitored would have between 20,000 and 200,000 Antarctic petrels, around 2,000 snow petrel nests, and over 100 skua nests each year. But during the 2021 and 2022 season, the numbers of nests dropped dramatically. Reporting in the journal Current Biology, scientists say climate change has caused increased snowfall, and so snow accumulation was significantly higher than in previous years, and that would have interfered with breeding. A new report by the FBI has confirmed that the Chinese government lied when they claimed that a large balloon which was zigzagging across the United States earlier this year was a weather balloon blown off course by the wind. A detailed examination of the balloon's payload by the FBI has now confirmed that it was indeed a sophisticated surveillance and signals intelligence gathering spy balloon, communicating directly in real time with the Chinese Communist government via satellite. The saga began back in late January, when the massive 61-metre-tall high-altitude Chinese spy balloon carrying an extensive 9.1-metre-long array of reconnaissance equipment, antennae, solar panels and propulsion systems crossed into U.S. airspace over Alaska. The Chinese Communist government claimed it was nothing more than a wayward weather balloon. However, its unusual flight path took it directly over numerous classified United States nuclear facilities and military bases, both in Alaska and in the contiguous United States. Now, the balloon had to alter its course several times, going against the wind, in order to achieve this feat, something weather balloons can't do. And on several occasions, the balloon started flying figure-8 loops to loiter over military bases longer. Again, something weather balloons don't do. It was finally shot down by a U.S. Air Force F-22 Raptor off the coast of South Carolina. Of course, by that time, it had completed its mission, and China had gotten whatever it is they wanted. The wreckage was collected by the U.S. Navy and Coast Guard and sent to the FBI's laboratory in Quantico, Virginia for forensic analysis, where the true purpose of the mission was exposed. The Biden administration was slammed for allowing the balloon to successfully complete its mission before being shot down. In response, Biden ordered the Air Force to shoot down more balloons if they enter U.S. airspace. A series of 3 smaller 20-metre-tall real weather balloons belonging to various enthusiast clubs were quickly shot down by US Air Force fighters in the skies above Alaska, the Canadian Yukon and Lake Huron over the next few days on Biden's orders. However, that practice was quickly stopped when it was revealed that the missiles used to shoot down these balloons were worth almost $500,000 each, and one required 2 missiles to score a hit. Now, that's $2.5 million in order to puncture some plastic. Now, in response to all this, that old spoon-bender Uri Geller has issued a press release warning not to shoot down UFOs because they could accidentally be hitting a spaceship from another world. Geller says spy balloons should be shot down, and the US government erred by not doing so the second the balloon crossed into American airspace. But he says it's important not to get spy balloons mixed up with what he describes as genuine, authentic UFOs visiting the Earth from multiple alien civilizations because they come in peace. Tim Mendham from Australian Skeptics says Uri Geller appears to be suffering from being out of the limelight for too long.
Uri Geller is definitely suffering attention deficit disorder, right? That is no longer sort of top of mind of people. But most people probably have never seen him bend spoons, etc. But he's out there pushing himself, and every time something happens, he issues a press release with Uri pontificating about it. And this was the case with those balloons being shot down. That was over the US and Chinese balloon doing whatever, others just being hobby.
They were purely weather balloons.
Yes, with stuff. And the others were probably similar.
He's been very honest with us, so remember that.
Right. So there's Uri saying, well, we shouldn't shoot down these balloons, but actually more importantly, we shouldn't shoot down UFOs. Not that we have. I don't know if anyone's actually seen a shot down UFO, apart from all the stories about Roswell, etc., which supposedly crashed, not shot down. But anyway, he's suddenly become an expert in saying that they come in peace. They're supposed to be nice, and they're not out to hurt us. In fact, they're here to help us sort of avoid nuclear war. I don't know how they plan to do that because they're invisible.
If I was a UFO pilot and I was passing the Earth, I'd roll up my windows and just keep going.
Yes, I know. It's if you came all this way, why don't you rebel yourself? Why hide amongst us and not do anything, apparently, right?
Mind you, if there were UFOs and aliens from another world and they landed and they said, take me to your leader, what would you do then? Would you really introduce them to Biden?
Is that what they're saying, or are they saying, take me to your German songs?
Yeah, well, that, yeah.
Yes. The whole thing is wrapped up in sort of a lot of cultural mess about UFOs. And UFOs, the evidence for UFOs is the same sort of evidence as for unknown animals and things. There's a lot of bad evidence around there. A lot of bad evidence, and very few sort of really serious evidence, even though some people who are UFO fanatics would say every dot they've seen in the sky is a UFO. But the nice thing about UFO proponents is most of them, not all of them, but most of them are actually serious researchers, and they're trying to get some scientific credibility to their area of activity. There's a lot of people who are out there, increasingly so, probably hoaxers and having fun, and it's increasingly easy to do that with modern technology of filming, etc. But by and large, a lot of the UFO fraternity are serious people looking for proof of their theory, and they're working out sort of justifications and, what does it mean? Are they multi-universe? Are they interdimensional? Are they from the future? Are they real? Are they little green men? What shape are the flying saucers? Blah, blah, blah. On and on you go. And the problem being that Uri, of course, pops up with his 5 cents worth and says, well, these are nice things. Don't shoot them down. Uri Geller, I reckon, is just adding to adding his crockery to his cutlery cupboard. So he's got a lot of broken flying saucers with a lot of bent spoons.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.